Okay, right. They are the astronomical equivalent of Back to the Future. And with the way the country is going at the moment, who wouldn't mind jumping through a black hole and skipping forward 5 or so years?
But do black holes really exist? And could you go back in time as well? David Moore of Astronomy Ireland joins us now. A very good morning to David. Now, when I read about this segment today, I was like, is this a joke? What are we doing, black holes going through time? But you say that it's actually true.
Yes, I mean, we can predict pretty accurately that if you travel very close to the speed of light, time will actually slow up. Einstein proved all this over 100 years ago. And the problem is that, you have to travel very far if you're traveling at the speed of light. But it turns out if you had a black hole nearby, you could just keep going around and around it. And one of the classic stories is the twin paradox. So if you can imagine, say, we took Jedward and we left John on the Earth and we sent Edward off to go round and round this black hole continuously. Then perhaps after a year of John going around the black hole, if he came back and he had been close enough to the black hole, the twin on the Earth may have aged only 1 year, but the twin going around the the twin on the Earth would have aged 50 years perhaps, and the twin going around the black hole only 1 year. So now they wouldn't look like twins anymore. And it's this paradox that came up originally when the whole idea that you couldn't travel fast in the speed of light or near black holes came up. And we know that would happen because we've put clocks on very fast aircraft and flown them nowhere near the speed of light, but as fast as we could. And their clocks did differ when they were landed.
Right. And just explain, the whole theory of the black hole, first of all. I mean, people have to get their heads around that first before they can start thinking about time travel, I suppose.
Well, perhaps after the Big Bang that created the universe, black holes are the most exotic things in the universe. We have
I think we have some images
some pictures here.
You can maybe explain, because obviously these are only artist impressions. We don't have any visual representation of the black holes.
There's an artist's impression of what a black hole might look like. Now, this wouldn't be a black hole on its own. This is one that shredded a star, and all you can see around the black hole should be a tiny dot in the middle of all that is the remnants of this star, which is slowly orbiting the black hole and falling in, and it's throwing out materials in those jets. And we see those jets in pictures of other galaxies around the universe, and the only thing that could be doing this is black holes. Another artist's impression showing a star nearby and the black hole pulling material off.
So what is the black hole,
squirting it out in jets.
How does the black hole form?
Well, there's a black hole as it would look in space. It was on its own. It's even bending the light from stars behind it. And the word black hole is because if you threw a ball, say, up on the Earth, you probably only throw it 100 miles an hour, even if you're a tennis server, maybe 150 miles an hour, it's going to go up and come down. But if you could throw it at 25,000 miles an hour, it would go so far up that the Earth's gravity would become weaker and it would eventually escape. And that's the escape velocity of the Earth. And somebody worked out, well, if the escape velocity of an object was bigger than the speed of light, then even light wouldn't escape off the surface, and it would be black, because anything that fell onto it could never get off. And that's where the word black hole comes from. Turns out they're actually the brightest objects in the universe, because when they get near a star and start shredding it, all hell breaks loose, and the light coming from that actually makes them stand out. And we've seen thousands of objects around our galaxy that are evidence of this happening. And in the middle of our galaxy is one giant black hole. The Sun, for instance, is 1 million times bigger than the Earth. And this black hole is at least 1 million, probably 4 million times bigger than the Sun. And it's probably previous giant stars, when they die, they create black holes, that have all merged together. The black holes have all merged together over the billions of years. And this is one massive black hole at the centre of our galaxy.
So this is like the effect you'd see in a sink. It's slowly, well, not slowly, all the matter is spinning around this hole, eventually being sucked in like some big giant Hoover out in the universe, is it?
Exactly. It's very similar to that. If you look at our galaxy from above, you'd see it looks like all the suds swirling down the plug hole. And at the centre is a black hole like that sinkhole where anything that goes in is not coming out, ever, by definition. You can never, ever get out of a black hole. It's one of the laws of physics.
OK, listen, I'm depressed enough with the economy and stuff. How far away is this black hole, and what's going to happen when we get into it?
Well, the nearest ones that we know of are thousands of light years away. And the nearest star is 4 light years away, so it's thousands of times the nearest star. So there's no danger of one coming near the Earth. So we couldn't actually do that experiment with Jedward. They'll be glad to hear. And to create black holes is beyond our technology. For instance, if you wanted to squash the Earth down so its gravity was intense enough to create a black hole, you'd have to squash the Earth to the size of a marble. Even the Sun, that's 1 million times bigger than the Earth, would have to be squashed down to something the size of Dublin. So we've no technology to do that, and that's not how you create black holes. The best way is there are bigger stars than the Sun, and when they die, they'll explode, and they crush their cores down into almost nothing, a black hole. And that's where we think most of the black holes come from. And over time, they all coalesce in the centre of galaxies, where we get the giant black holes.
And can you explain in layman's terms why it is impossible? If something goes in, it's not coming back out.
Yeah, well, we've done this quite a lot, and in March we have a lecture about the big reactor collider they have on the French-Swiss border, where they're smashing particles together to recreate the Big Bang. And when these particles go around at very high speed, they use more electricity than a whole city would use to get tiny particles up to incredible speeds, very close to the speed of light. They get heavier. And that's exactly what the theory of relativity predicted would happen. And also, anything that happens on them, we can check, because some of these particles decay, they explode spontaneously. And they don't explode spontaneously when they're going very fast, which means time slows down as well. So we know that the theory of relativity works very well. And that's how we know about all these properties of black holes, even though we haven't got one sort of in a pet zoo to actually test. We can predict it pretty accurately and do other experiments that show that a big object is just going to do these kind of things.
And you can say quite safely that your description of it, from an astronomer's point of view, is quite accurate, even though they're so far away.
Yeah, I think we have an animation which shows the black hole centre of our galaxy, and you'll see a little cross where there's nothing, and then other stars going around it. And what happens there is that the stars are very big. They're going around something unseen. The object must be bigger than them. Why isn't it glowing? And the only answer is it has to be a giant black hole at the centre of our galaxy.
Okay, David, the latest edition, the next edition of Astronomy and Space out next week, is it?
That's right. The March issue will be out in the middle of next week. The February issue is on sale already. There are evening classes running about black holes and everything else in the universe all across the country. So check out the website, astronomy.ie, because we even have a Valentine's night lecture about the romance of astronomy.
You're heading into astrology there, aren't you?
Okay.
Well, astronomy can be fun as well, and of course a lot of people have gained romantic inspiration from the stars. It's a fascinating subject, and a night sky is a beautiful sight to behold.
Absolutely. Okay. David, thank you so much.